So in this case, we have the situation where there's not a greater than or equal. It's just greater than. So if we wanted to do this, then we need to make sure we first find our point of intersection. And so first things first, though, what's the keystone that we're going to be using? What are our keystones here?
Well, you already mentioned one in the last video.
We're going to keep naming them. So what's the number one keystone for this exercise?
I was going to say height.
Yes. Look for when your height
You're saying that we have to see what
obeys
we have to see g of x
the
because
greater than.
well, actually both, because you
Or less
shade the one
than.
which is not correct. If you have to see the height of both of them and which one's incorrect, you shade that, right?
Yes, you're looking for when the statement becomes true. You're not going to really know until you graph it or solve it, right?
Yeah.
But you know in the back of your head that if you can save that as a grandfather cell, right? Then when it'll appear to you once you find your intersection, your solution coordinate, right? And so what we're going to do here is we're supposed to model this. So let's do 3x minus 6 greater than. We're going to make sure we put this off to the side. And what we can do is
add 2x.
Well, before you do that, I like to put it in equality form first to find that point first, that coordinate first.
Oh yes, equality.
So we need to find equality
for all.
Find your equality or find your coordinate solution first.
Yeah. Whenever I think of equality, I think of equality for all.
Equality for all. It's funny. Definitely not the case of rising and now one's positive and one's negative, right? So naturally the height's going to change eventually. It's common sense. So the first thing we're going to do, well, let's go ahead and now, since we've got our keystones out of the way, let me shrink some stuff down and we can put a graph up here. Let's put this to the side, if I may. I'm just running out of space. So we need to find our coordinate. I'm just going to put the steps. I don't need to do the arrows, I guess. I can just do steps. And then what I can do is I can graph this by hand if I want to, just to kind of demonstrate that you don't have to have, it doesn't have to be the best graph, right? But, since I have Mathematica, why not use that, right? So I'm just going to do that anyway. So just to test to see whether you're paying attention, what is f of x? What's that function?
F of x is 3x minus 6.
Thank you. Copilot. And g of x was what?
Negative 2x plus 4.
Negative 2x plus 4. Thank you. So then I go to the graph, or I'm going to plot this real quick for us. Sorry. Go. Right, okay, good. Oh, this one's nice, actually. I like this. And this one's very useful. Wow. I made an isosceles and didn't even see it. Or did I? No, it wasn't isosceles, but it is a nice little triangle. It's obtuse. All right. Did I get this or not? Let me see. We're learning geometry as we go along. Probably forgot. It's not good. All right. I'm going to put it up here for convenience. Doesn't mean you're always going to use it. Okay. So we can already see that looks like that's going to be y equals 0 as part of the solution set. But that is nice. But let's see what happens when we run our math. If we add 2x on both sets.
I think it's 2, 0, but let's see.
Look at that. That's how fast, right? You're correct. Because if you put 2 back into that just by looking at it, and you can put it in g of x or f of x, you encourage people to try. That's 6 minus 6 is 0, and 2 times negative 2 is negative 4 plus 4 is 0. I'm going to show that one. G of 2, negative 2 times 2 plus 4 is equal to 0. So you are correct, Padawan. It is 2, 0. Good job. And you saw that on the graph, and your guess was accurate because when I did the algebra over here, it validated that. Now, what I didn't do in the last video is I didn't test the coordinate solution into this. So sorry. But what we need to do then is see, you might plug some test numbers in here, right? Because you know if the coordinate solution is 2, then the reasonable ones to test would then, that would be what? You would pick 1 before 2 and 1 after 2, right? Okay, so why not use simple numbers, right?
Right.
And do like a small truth table. So I put X right here. I keep it simple. Use the KISS method. And
what?
the KISS method, it means keep it simple, stupid.
Oh.
If you've never heard of that,
No, I didn't.
Teachers use that a lot. And I just picked it up as it went along.
You invented that. Good job.
I didn't invent that. No. One of my supervisors from years ago mentioned that when I was tutoring. And I was like, okay, I'll keep it simple. So now we test it. Let's plug in the number and let's test the inequality, right? Is it true? This is going to tell us when our height is, like when our statement for the heights are true. If we look on the graph, it's going to be after 2 comma 0, but we want to show, like, what if you had no time, you just wanted to do a table instead? Well, you can do that too, right? If you didn't want to graph it, you could do that too by testing numbers. Once you find your number, the table is a tried and true. You'll get it every time. So then we're going to go ahead and do that. We'll plug in 1 minus 6. That's is going to be equal to negative 3. And then we'll plug in over here negative 2. In fact, I'm trying to make this not messy, right? So 3 times 1 minus 6 is negative 3. And then 2 times 1 plus 4 is what? Positive 2, right? Is that true?
No.
So then we strike a line through it.
One ain't gonna work.
Now we test the intersection solution, right? Or the coordinate solution. Let's plug that in. So 3 times 2 minus 6 is 6 minus 6, which is 0. Negative 2 times 2 plus 4 is negative 2 times 2 plus 4, which is 0. Is that true if it's just greater than?
No, 0 cannot be greater than 0.
Right. So then we mark that out because we have an open. We don't have a greater than or equal. We just have a greater than. Now let's try 3. If you plug 3 in, you have 9 minus 6, which is 3.
And negative 2 times 3 is negative 6, and negative 6 plus 4 is negative 2.
Very good. And is that true?
Oh, yes.
So then guess what? After 2, it became true. And if we were to continue on putting these in here, you'd have 6 over that also true. And you'd have 5 if you plug that in. And let's see, 15 minus 6. You see what I'm saying?
Wow.
Even if my numbers are wrong. So 5 and negative 10 plus 4 negative, that's also true.
Wow.
So that's exactly what I've been demonstrating over here, that the actual, for these values of x, the heights, 3 height, let's say it's feet. 3 feet's greater than negative 2 feet beneath the ocean. 6 feet above the ocean is greater than negative 4 feet beneath the ocean. 9 feet is greater than negative 6 feet beneath the ocean. If the ocean was an orange line, I'm just saying, just throwing something out there.
So that would mean that the left side.
Now, in order to determine, that would mean that the left side's incorrect, right?
Yes.
So your solution of validity, you would say that the solution set.
That would make sense, because no wonder it was 2. X equals 2 because the last number that is not true, that it's 2, and all the numbers up to that is just true.
So the solution set is x is 2 to infinity, right? And we don't do a bracket, we do open, because it can just touch it. It can never be on it, because remember, that's not, when it's just greater than or less than, you can't be equal. Even though the coordinate solution is 2 comma 0, we can't actually be on it for the statement. Say it's a landmine. You can get as close as you want to that landmine if you're silly enough, but the second you hit that red dot, you're at 2 comma 0 and boom, game over, man. It's game over. I'm not going out there, then things running around. Count me out. So that's definitely, yeah, right? Does it all make sense?
Yes. The table when you show it now, it starts making more sense because x equals 2, right? The last number the incorrect number is 2 and all the numbers after that work. So that makes
Yeah,
absolute
but
sense now.
visually it makes sense though. That's what I was saying. Is that's what I'm saying. That's those numbers. This would have been this would have been 6, right? This would have been or that would have been like yeah, that would have been 6. This would have been -4, right? This would have been 9. This would have been -6, right? And so on. This would have been 3. This would have been -2. So that height's greater than that height. That's great. That height's greater than that height. That height's greater than that height. Your coordinates would have been for the y coordinates, right? You would have had I'm just doing the y coordinates. You know what I mean? It's not like
Right.
specifically 9, -6. I drew this the best way I could, but I think you get the point here, right?
Yes.
Okay, good deal. We got it. Count us in. Hopefully that's enough. Now, wait. There's one last thing I wanted to demonstrate, and that's the fact that let's say I'm trying to come up with one where the alligator symbols, because if you were to solve this, I shouldn't say alligator, with the inequality symbols, 3x minus 6 minus 2x plus 4. If we were to just simply solve this as it stands, we definitely could get our solution set, right? We would have 5x is greater than 10, x is greater than, I'm sorry, x is greater than 2, and our solution set would be represented as 2 to infinity, right? So
Right.
yeah, quick and easy, no brainer. But what do you learn from it? Nothing. You don't know what's going on. You don't know what height's greater than what height. You're not modeling
Right.
anything. Where's the common sense? How do you remember it? You really kind of don't. I mean, this is just how a spider would weave its web. It's very
Because
insect-like.
you don't
It's not higher
understand. You don't
mammalian
understand.
thinking.
Basically, it's how you
Respectfully.
just don't understand how math works.
Well, it's just really base level taxonomy. You're really thinking just as much as a spider could think. You're not thinking any more anything other than just repetitive motions. In fact, I would argue that a spider could do more, really, algebraically. So, primitively speaking, of course, he can't organize syntax like a mammal and specifically human being or dolphin, and etc. But if we can go to kind of a situation where, what if we had like maybe -5x was equal to, we could say greater than, oh, and also just before we get on to another example, when you model these solutions, if it's just a greater than symbol on the graph, then I believe you've got to just dot these in, right? Like your solution lines, I think, are dotted like that. That's to represent that it's not greater than equal. It's just greater than or less than. So you dot your lines when you graph it. That's just notation. That's how they show that it's not a greater than or equal. It's just a greater than or a less than.
Yeah.
Respectfully, again, not a greater than or equal to or less than or equal to, but just a greater than or a less than statement. You got to dot the lines. Does that make sense?
That makes sense.
Okay. Now moving on. What if you just had, we'll start simple if I can't think of anything, right? One of the things I want to do is look for a solution like this, but what I'm going to do is I'm going to just use a constant to represent this situation. And I'm going to put like maybe let's just make this easy. Let's make this a -3x. And let's make this a +6. And so then visually over here, you've got 1, 2, 3, 4, 5, and then 6. That's 7, 8 just for kickers. And then I want to go down a little bit here. 5 and 6. 1, 2, 3, 4, 5, 6. And then I've got 1, 2, 3, 4, 5, 6, 7, 8, 8, and then So then I'll just do 1, 2, 3, 4, 5, 6, 7, 8. So if you just solved it like this, I'm going to do it the wrong way. You might think that you've got the solution x is greater than -2, right?
Right.
You think that's a solution. Is it though? Let's see.
No.
Let's see why. Let's understand why. We missed a symbolic rule when we do this. And this is the third way, right? So let me go ahead and graph them first, right? And if it's like we're just going to dot our lines, that's going to be y equals 6. And then the other function is y equals -3x, which is down 3 over 1. So I'm going to do that one maybe in orange. So down 3 over 1, I have that. And then you can reverse it, go up 3 and back, right? And then maybe up 3 and back, which should get you to 6, of course, and so on. So then you got this line that's negative sloped, -3 slope going down through the origin. It's not to scale, but so then now the inequality says that -3x is greater than 6 from the wrong one. I'm going to say the wrong one, right? It's wrong because -3x is not greater than 6 for x greater than -2, is it? I want you to look at that, because why is that? The keystone is our heights, right? So over here, if we follow the statement, this is not correct. This is incorrect. Certainly incorrect, just by looking at the graph. And why is that? Why is this incorrect? X is definitely not greater than -2, because if you look at this, this is going to be y is equal to -3x, and our function over here was y equal to 6. Well, -3x has to be greater than 6 for some x value. It's only greater than that for everything before -2, because -2 is our solution point. Our coordinate solution is -2, 6. That's its intersection point, or coordinate solution point, however you want to say it. But then what happened? Well, let's do just one test value beneath 2. If I do -3 times -3, then I get 9, and that's greater than 6. If I do -3 and -4, I get 12, and that's greater than 6. So it seems that -4, -3, so it seems that anything before -2 is correct, not after.
Yeah.
So then that would indicate that your solution set needs to be like this. You need to have this solution. You need to have anything from -2 on your number line to -infinity. Or you would write that as x solution is going to be less than -2. So what rule did we miss? Now, we're going to tie the rule together. The rule is when you divide a negative number across the inequality, you have to switch the sign.
Yeah.
And that's how we deal with that. But nobody knows the why we did it. I am showing you here the why. Why, not why, but the word WHY. Why we did this. So if you divide by that negative number, you switch the sign, and this is all the reasoning as to why logically. So that means now you got x as, we don't keep it, we switch that direction, and that would be the solution set. Or you could write it as -infinity, -2.
Because if you substitute -3 for -2, you just get 6 is greater than 6. That doesn't work. All the numbers before -2 don't work.
All the numbers before -2 do work. All the numbers after -2 don't work.
Oh, sorry. Yeah, that's what I meant. I switched it up.
Yeah, you're good. I figured. I just wanted to make sure. Sounds about right.
Yeah, like -3, that worked. -4, that worked.
So in our earlier videos, when we were dealing with quadratics, dealing with these, I'm surprised you would even get close to understanding it, because that is the key concept that you just identified in the past 2 problems, or 3 problems. So in lieu of that, I'll give you a worksheet for you to work on, okay?
Okay.
But for now, let's go to our next lecture, that being matrices.
Anakin, Chancellor Palpatine is evil! From my point of view, the Jedi are evil. Well, then you are lost! This is the end for you, my master. Ninja, vanish!